This episode of Fluid Power Forum is sponsored by IFP Motion Solutions Incorporated, the leader at engineering electronics into fluid power distribution. IFP spans the 13 central states from Minnesota to Texas. For more information, visit ifpusa.com.
And our human eyes are really, really good at identifying differences or similarities. So as you're looking at it from cycle to cycle, and it's the same segment, so it's not trying to look at the whole dig, dump, and return of an excavator cycle. It's just the dig portion. So it's a much smaller segment to look at. You can see what areas are similar between each cycle and which ones are different. So if there's differences, we try to understand if the operator maybe miscommanded something. But there's similarities, particularly if we're going after efficiencies, right? Those are where we believe the biggest bang for our buck is going to happen. Because if that inefficiency happens across to a similar magnitude across multiple cycles, that's likely a good area for us to focus in on and improve.
Welcome to Fluid Power Forum, a podcast of the National Fluid Power Association. I'm your host, Eric Lanke, and it's my job to interview interesting people who are moving fluid power technology forward. If you'd like to be part of the show, we ask that you follow us on LinkedIn. You can find us there at the National Fluid Power Association. And when you're online, be sure to share those interesting and innovative uses of fluid power with our hashtag #OnlyFluidPowerCan. If you see an interesting application of fluid power and you want to learn more about it, just share it on social media using our hashtag #OnlyFluidPowerCan. And you just might hear it discussed on a future episode of Fluid Power Forum. Also, please subscribe to our show. You'll find us on all the popular podcatching services. Wherever you find us, go ahead and subscribe. And then give us a quick rating. Those ratings really do help promote the show and allow more and more of our friends in the industry to join in on these important conversations. On today's show, my guest is Corey.quinnell, Vice President of Global Engineering at Husco, a company known for designing and manufacturing hydraulic and electrohydraulic controls for mobile equipment across worldwide markets. Corey recently presented at the Advanced Hydraulics Conference that NFPA hosted at the August 2025 IVT Expo trade show, and his presentation was a fascinating data-driven dissection of an excavator machine cycle. So we invited him into our forum today to learn more about that topic, about data analytics in the fluid power system in general, and the different lessons that can be learned about for the industry more broadly. So, Corey, welcome to Fluid Power Forum.
Thank you. It's good to be here.
I was glad to have you on the show. I was at the presentation that you gave at IVT. It was, as I said, it was a fascinating analysis, and I'm excited to have our listeners hear more about it. Tell our listeners a little bit more about yourself, though, first. What is your background? How did you come to work at Husco?
So I started Husco directly out of college. My major, I completed my Bachelor of Science of Computer Engineering at MSOE. I started Husco doing control systems for excavators, backhoes, telehandlers. And then as I went through and did those control systems, writing those software, basically learned more hydraulics at that time, and eventually continued to progress through my career, leading hydraulic valve teams, led also some of the cartridge initiatives and stuff that we've had here at Husco. Dabbled into the global manufacturing engineering space for a couple years, and now, as you said, you talked about, I'm the Vice President of Global Engineering.
Yeah, well, that's an interesting career path there. So you're a computer engineer, you said, by training.
That's correct.
Yeah. So the MEs treat you all right at Husco?
Yeah, they do. They do okay. I'm definitely one of the few non-mechanical engineers at Husco.
Well, it's interesting because the industry is becoming more and more proliferated, if you will, with computer engineers and data managers and all kinds of that kind of stuff. So that's interesting.
Yeah, I agree. There's a lot of blend between mechanical engineering and computer engineering, or software engineering, electrical engineering, especially in the off-road space. It's really starting to blend, where having competencies in each of those areas is important.
Absolutely. Yeah. Well, and tell us a little bit more about Husco as an organization. If someone's not familiar with them, what do they do?
Sure. So Husco's a global engineering and manufacturing company. So we have plants all across the world. Two main divisions, major divisions. One is automotive. Think of small little cartridge valves. So if you were to open up the hood of your car and saw some electrical wires connecting into the hood of your car, there's a high likelihood it's a Husco cartridge. So do a lot of different engine cartridges, transmission cartridges, and other suspension type cartridges on the automotive side. For the side that I work on is the off-highway side. So think of anything that's not on the road, like an excavator, backhoe, skid steers. We also work on agricultural tractors, combines, and then also material handling, fork trucks and stuff like that.
And you guys are headquartered in Waukesha, Wisconsin, right?
Yeah, that's correct. Our headquarters in Waukesha, Wisconsin, several plants here in the U.S., one in Waukesha, Whitewater, and then one in Iowa, and then another plants in engineering globally in the UK, India, and China.
So you really have your fingers all over the world, it sounds like.
Yep.
Yeah.
Yep.
Right. Well, your presentation, as I said in the intro at IVT Expo, was really about data analytics, about using data to better understand the excavator machine cycle. And we want to learn more about that and how you did that. But maybe start at the very beginning. If people may, what is data analytics? What is that? How would you define that?
So I'll talk a little bit like what we did is, so if you think of like one of these machines, and we'll take an excavator because that's what my presentation was about,
Sure.
is we'll put lots of sensors on the excavator to detect what the operator is trying to command and what the machine is actually doing. So we record all of this data, and then it's like you have all this data, what do you do with it? So kind of the analytics portion of it is developing software to go through and analyze all of those signals that you've recorded, that then you can eventually graph and provide insights into how the machine is actually running. So for example, one of the key metrics that we look at is efficiency. So how much fuel went into the excavator versus how much dirt did the excavator actually move. So those are some of the metrics and stuff that we get out of our analysis.
And the sensors that you're talking about, are they kind of standard equipment now, or is this, you had to put this on a test rig to do this?
So I think as it continues to, as the industry continues to advance, these become more and more common, but typically what we end up doing more of an instrumentation to get like all the cylinder positions, all the cylinder pressures, some of the other advanced pump signals. There's more signal breadth that we want as we're going through and doing this to development to help identify and ease our engineers to find what areas that we can improve on. But as you get into production, a lot of those sensors and stuff are pulled back because they're not actually needed to run the machine.
Okay. So this is something that you're doing in an experimental fashion, but it gives you good information about how the machine will actually more efficiently operate in the field.
Yeah, that's correct.
Yeah. Okay. I know one of the pillars that you discussed in the presentation was about having a standardized process for this. Maybe you can talk about that a little bit more.
Yeah, this is one of my favorite parts of the presentation because I think it's often overlooked. Maybe 15 or so years ago, we used to have all engineers. We were good. Husco's always been good at taking data, but our engineers would spend time, developing the graphs and then putting it into a presentation to go through and review. But as you think back at that all takes time, right? The engineer needs to figure out what graphs to make and what's useful. And then as we go through and try and present those graphs to like an engineering team to identify, right, how can we improve that machine? Then engineers spent more time trying to understand what those graphs looked like, right? And what calculations were behind them. So you're wasting all of this time. So then what we've done is we developed this standard process. We now have standard graphs, which mean it's the same graph or the same kind of analysis every time with known and proven calculations. So now we come into a meeting, these either it's in a presentation or sometimes you still print them out in page form.
Right.
Everybody dives in and we're immediately able to start talking about takeaways and finding the opportunities on the machine rather than trying to spend time and understand what actually is being presented.
That's interesting. Yeah, one of my pet peeves is, when somebody will produce a set of graphs and the same data series is a different color on graph 2 than it is on graph 1. And
yes.
That kind of thing, right? Because
it's interesting you talked about that. Yeah. So like one of the graphs I showed during the presentation was, there wasn't a lot of legends on some of our stuff because as we got more and more standard. We ended up and we went to legends and then we actually went away from legends because you can see we've all standardized the line colors. So now we all know what colors each
Okay.
functions are,
Right.
to
Yeah.
where it was just our standard, and now we had more page space to show more graphs and actually get deeper into the details.
So standardized colors is really important. I bet standardizing the scale is probably really important
Yep.
too, right?
Yep.
So yeah.
Yeah, the scales, yes, yeah, you got it.
Yeah.
Especially as some calculations, depending on how you're doing it, can really, as they get closer to zero, can really, especially if you're dividing by it, can
Right.
get really large, and then it zooms way out and you can't see any of the data. So yeah, I agree. So we've standardized a lot of our axes and what range are shown so that it shows a good amount of the data to make the decisions off of.
So I'm curious, like how many people are involved in this project? It's not just you, obviously.
So this is something I would say that our engineers, it's mainly a lot of our process was developed through MATLAB. So we just basically started writing the scripts and stuff in house at Husco. And as we continue to get more and more machines and more opportunities, everybody likes to put their next flavor onto it. So we continue to grow this over the years with, well, I would say there's probably a dozen or so Husco engineers that have had their fingers into this, our process here of making the graphs and collecting the data, especially as new sensors and stuff come out, right? Sometimes there's better sensors that we'll not want to bring those in. And because maybe they're measuring something a little bit different, we'll need a different algorithm to calculate it into the same fashion into our flow. So it's an evolving process, and we continue to grow and develop it, but it works well for us.
We'll continue with the show in just a moment, but first let me share some exciting news about our Fluid Power Forum podcast. We're launching Fluid Power Forum Plus, a premium listener membership offering exclusive content and special event opportunities for our most dedicated listeners. When you sign up for free on the NFPA website, you'll be able to unlock exclusive episodes, live recordings, transcripts, and invitations to private networking events, each offering even greater insights into interesting and innovative applications of fluid power technology. The first of our special events is now being planned for the NFPA Technology Conference being held at the ConExpo ConAg Trade Show in March of 2026. Fluid Power Forum Plus members will receive discounted registration for the conference, plus an exclusive invitation to attend our live taping of the podcast there, and a members-only networking reception following that taping. This will be a huge opportunity to gain insights into the innovations happening in fluid power technology and to meet up with fellow listeners and build your network. And that's just the start. More exclusive benefits will be announced soon. To register, head over to nfpa.com/plus. That's nfpa.com/plus. And so one of the key pieces, I guess, is, as you collect all this information and as you standardize the way it's presented and analyzed, you're looking for common patterns, right? So in the raw data, how do you go about doing that?
Yeah. So as you think about, we talked about the hundreds of sensors, and if you were to look at the raw data, right, and you try to graph those are really difficult. Yeah. So what we've done is we have found, I would say, key signals from a Husco perspective on what should be shown. Some of them are calculated, some of them are actually raw, but excuse me, back to the standard graphs, those are really the key for us, right? So once they're set up, the way we lay them out, you can see them cycle to cycle. So if we talk about the dig cycle of an excavator, I may have a sheet that have maybe 5 to 10 dig cycles on there, and our human eyes are really, really good at identifying differences or similarities. So as you're looking at it from cycle to cycle, and it's the same segment, so it's not trying to look at the whole dig, dump, and return of an excavator cycle, it's just the dig portion, so it's a much smaller segment to look at. You can see what areas are similar between each cycle and which ones are different. So if there's differences, we try to understand if the operator maybe miscommanded something. But there's similarities, particularly if we're going after efficiencies, right? Those are where we believe the biggest bang for our buck is going to happen. Because if that inefficiency happens across to a similar magnitude across multiple cycles, that's likely a good area for us to focus in on and improve.
So those are some of the actionable takeaways that you can get out of this process, right? When you look at the multiple cycles and the differences between them, talk about that a little bit more.
Yeah, correct. Yeah, so I would say that's how our engineers, look at those similarities or differences, and then finding out the opportunities. I think that serves mainly two big keys for us. It gives us the engineers the ideas if we're the ones who are developing the valve for that particular machine. It gives us the area that we need to improve, and then that then lifts off and goes into our design process where we can adjust our scope of work in order to hopefully reduce that inefficiencies or improve the controllability, whatever the right target is for that particular project. Some other things that we do with this is sometimes customers will ask us to offer, they want like that value proposition. Right. So because we have all this data, we're then also able to go through and estimate, if we were to improve this to what we think is a reasonable level, we would save X amount of fuel and it might cost you Y amount.
Yeah.
Right. So you can go through and have this data-driven way to provide, is this valuable to the end customer? So our customers typically are the major OEMs on the off-road construction market, right. But we can now present to them with pretty high certainty of, okay, if we make this improvement, or maybe we need to add this device or something, it's going to cost X. Your customers will experience Y. Is that the right value proposition that you want to go after?
Interesting. Yeah. I mean, there's a lot of power in that, it sounds like, to be able to kind of show show the work behind those conclusions, right?
Yep.
Yeah.
Yeah, exactly.
All right. Well, so that's a nice review of kind of your process for this. Let's talk about, you actually applied this then to a particular excavator or a particular machine cycle on the excavator, right?
Oh, that's correct. Yes.
So tell us a little bit more about that specific project, and what did it reveal? What did you learn?
Yeah, so when the excavator project that we talked about during the IVT presentation was for a large excavator, and I highlighted some of the different areas, like during the dig operation, we found some inefficiencies. It only happened once, but it was due to the operator got into the slew command. And for those that don't know, slew is what makes the upper carriage spin, which typically you don't use during the digging portion of a cycle. So that was an area that I pointed out that says, hey, even though this is an inefficiency, back to those standard graphs and be able to see those patterns, it wasn't a continuous pattern that the operator continued to hit the slew. So it was likely just either they hit a rock and the machine jarred a little bit, and that resulted in a slew command. So it wasn't something that we would go after. But then another area that I talked about was there was the arm where you could see during the dig had a large amount of back pressure. And this is very common for us to see. So as we go through and we look at this, there's two negatives that happen with that arm having high back pressure. One, it reduces the force in the arm. So the more force you have in the arm, the think of it as the stronger you are to dig through the earth, right? So you want to maximize that force. So basically that's limited with the higher back pressure. And then the other thing that it does is it raises the actual pump pressure required to push the arm through the soil. So when that pump pressure raises, because you're on the power limit, it puts you further on like the pressure limit of the power limit, so that you have less flow available. So if we were able to go through and reduce that back pressure on the arm, you get two benefits. One, the operator would see that the arm feels stronger more through the dig, and it would go faster, so your cycle time would reduce, which is usually a really good benefit to provide to the customers.
Absolutely. So this was for a particular customer that you did this, or this was a generic experiment that you did?
This was for a particular customer.
Okay. You don't have to tell me who.
Yes.
Yeah, you don't have to tell me who. I'm just.
Yeah, that's okay.
So it had very close practical application for them, it sounds like.
Yeah, very, very close. And maybe to step back just a little bit, we've done this process on over 100 machines, whether it be on excavators, backhoes, mini excavators, skid steers, dozers, wheel loaders. We've done this same process across those machines and over 100 different machines. So different machine sizes across multiple OEMs. So we've had lots of opportunity to refine this process and kind of validate how well it works for Husco.
Well, I got to ask, with that kind of experience, are you seeing the same things over and over again on all these machines, or is it all different in terms of where the improvement areas lie?
Yeah, it's for in particular, like with most of the stuff we've done is on digging. So think of large excavators, backhoes, and mini excavators.
Right.
There is a lot of the same things come up. The arm back pressure, like I talked about, that is a very common thing to see. And it has some design challenges with it, but finding ways to design around that can really set you apart in the market and really give the OEM a nice efficiency boost and perceived power boost to the end customer.
From a design perspective, are we talking about that's a design element at the machine level or at the hydraulic system level to fix that?
Yeah, I would say typically the hydraulic system level.
Okay.
So whether it's in the hydraulic valve, right? So whether a lot of it comes back to how you control regen and what some of the requirements are at lower idle in order to set that back pressure.
Okay.
But there's some different things you can do to work around it, and a lot of new systems and stuff are as efficiency continues to push, or as we get into battery electric, and we need to get more and more efficient. Those areas are being more and more addressed.
What are some of the more novel things that you guys have discovered through this process? That you don't see every day.
Or no, one thing I think is I think I talked about a little bit during the IBT presentation, or maybe two things.
Yeah.
One is like bucket cylinders. It's an interesting thing is that there is an interesting connection between the bucket and the arm when you're going into the dig. So if you kind of picture that, you can kind of think that, hey, as those forces translate through the dig,
Right.
you can see there somewhat of a coupling. There is actually some inefficiencies due to a lot of the bucket cylinders, I would say, are oversized for a digging machine. And a lot of it is, as we learned from the OEMs, a lot of it has to do with bucket breakout force. So how much force can the bucket do? So that's like a marketing ploy, which you're not typically always at max pressure with the bucket to break out. So that marketing material then translate into actually a machine inefficiency because like I said, that coupling between the arm and the bucket creates an inefficiency.
Okay.
So that was an interesting thing for us. One other one that I'll talk about is typically the operator, finding ways to kind of limit the operator from commanding or erroneous commands. I talked a little bit about the slew, but one of the common things that operators will do on the slew is that when they go to brake, they'll counter rotate with their joystick, and what that typically does is just put pump pressure over a relief valve. It doesn't add it adds a small amount of additional braking, but it's not worth the extra fuel spent by putting the pump to high pressure and high flow over the sluice cross-port relief valve.
Yeah.
So there's some of that operator training has been some of the areas that I think I don't know if we would have, like, as we started out, that I would have projected that we'd been able to create this manual of teaching operators what to do and not to do, but
Right.
through the data and understanding how the machine operates, there's certain things that are just easier to do with the operator.
Yeah, that's interesting. So not every solution is a new valve, right? Some solutions are like, don't do that anymore, or learn how to do this better, kind of thing, right?
Yeah. It's just education, right?
Yeah, right. Well, I know that Husco has done some work in autonomous functionality as well for excavators. I think one of your colleagues was on the show some time ago talking about that. So, I mean, the whole make sure the operator is better is an interesting conundrum when there are fewer and fewer operators, right? So it opens up a lot of possibilities in terms of what the technology solution could be in that space.
Yeah, agreed.
Right. Well, is there anything else about the data analytics process on that excavator that you wanted to tell us about? Any other insights that you gained?
No, I think that's the right amount of, as we went through and talked about it during the IVT, I think there's a lot of good discussions around it. And I think, those were definitely the highlights. Every machine's a little bit different, right? Especially if you start talking about regionally, or whether a machine is targeted for the US or maybe Europe or China, there's always different goals and maybe different ways that those machines are set up. So there's some geographical differences that we see throughout the data. But in the end, physics are physics and the math works. Just sometimes our takeaways are a little bit different, or the end controllability target and or efficiency targets may change based on customer and target region.
Yeah. Well, I know not everybody is doing this kind of analysis, right? So I wonder if I can ask you to think a little bit more broadly, like what is the potential future application of this in the industry? Is this, should more people be doing this kind of analysis? How does that work?
Yeah, I think we start to see probably over the last couple of years, we are seeing more and more people doing this type of analysis. I think it's becoming more and more commonplace. I think as machines become more electrified, I think some of the sensor data becomes easier to get. And then also adding sensors once you kind of already have a hydraulic computer already on there controlling the machine isn't a lot of overhead to do some of this baseline data. So I think that's one area that's kind of pushing us to that's lowering the hurdle. And another spot is as we continue to look at new fuels and new energy sources, right, that optimizing of the hydraulic circuit is still high on a lot of people's radar. So there's a lot of good push to really understand how the machine is operating, where the inefficiencies are at, and how can they create the hydraulic circuit that works best for that machine.
All right. Well, that is going to wrap things up for this episode of Fluid Power Forum. My thanks again to Corey Quinnell, who has been my guest on the show. If you want to connect with Corey, learn even more about their data analytics process, you can reach out to him via email, and we will put a link to his email address in the show notes for this episode. Remember, if you like our podcast, and we hope you do, please follow us on LinkedIn. You'll find us there at the National Fluid Power Association. And make sure to keep sharing those interesting and innovative uses of fluid power with our social media hashtag #OnlyFluidPowerCan. We do want to hear from you about the kind of topics you'd like to hear us talk about on the show. Fluid Power Forum is a podcast of the National Fluid Power Association. I'm your host, Eric Lanke, reminding you to join us next time in the forum.